Alrighty, trying to simplify these radicals here. Remember, this is a square root. Square coming from our exponent of 2, which is square, right? Now, square root, if you recall, there's an invisible number here that's a 2. Because of the square, it's considered a 2. So, a square and a square root, they're inverse of each other. They would cancel each other out. That means that all of this stuff would kind of like disappear, right? Leaving you only the x, so you would only have the x left over. Okay? Now, when we're working with this, we have to simplify our numbers because, again, we need to make squares so that we can get rid of that square root. I can find two numbers and multiply to 32. Yeah, I heard somebody say 8 times 4, right? That's 32. But I should be able to continue breaking down this tree until I reach my prime numbers. Again, prime numbers are what? Numbers that can be divided by itself and the 1. So it can be a 2, it can be a 3, it can be a 5, it can be a 7, 11, 13, on and on and on and on. Only by itself and 1. Not the 1, because you need two different numbers. Itself and 1. And they have to be two different numbers. Well, the 8 can continue. 4 times 2, and I found a prime number. So this part of the branch is going to close. And this one's going to continue. That's 2 times 2. I can close it. I can close it. So this branch is closed. On the other side, I got 4, which is 2 times 2. And I can close those branches there. And I see here that I have a pair of 2's right there. I have another pair of 2's right there. And I have this guy by itself there. But if I have pairs, 2 times 2, I can rewrite it as 2 squared. And everything here is under the square root, right? 32, another way of writing 32 will be 2 times 2 times 2 times 2 times 2, which is all of these 2's right here. If you put it in a calculator, that should be 32 right there. So that means that that pair of 2's was under the square root, or inside of the square root. This other pair here is also a 2 squared. Okay, 2 times 2 is 2 squared, and it's also under the square root. This other 2 is still under the square root, but by itself. And you can do the same thing with the variables, okay, the letters. I have 1m because there's an invisible 1 power. Well, there's nothing I can do there. It's still under the square root, right? I've got the p squared. I can write it as p squared because I need squares. There's 2 p's right there. And I also have the q, which is under the square root, or inside the square root. So anything that has the square, I can cancel those. They're eliminated. In other words, all of this is gone, and it's just that 2 right there, right? All of this is gone now, disappeared, and it's just a 2. All of this is gone, and it's just that 2. All of this is gone, and it's just that p. So here all I got is the 2. Here I have the p. So in other words, they're not inside the square root anymore. They're outside. I multiply any numbers that are outside. 2 times 2 is 4. I get all the variables together. There's only a p that's there. And then the ones that remain on the inside, then I keep them on the inside, which is the 2, the m, and the q. And we have simplified this radical.